In this video lesson, we will learn about fractional exponents. So we already know about regular exponents. We can take any number to a fourth power, a fifth power, a second power. We can even do negative powers in the zeroth power. So for example, we know that 3 to the fourth is just 3 times 3 times 3 times 3. 4 3's multiplied together. And even a negative exponent like -2, if we have 7 to the -2, it's 1 over 7 times 7, 2 sevens. But what happens if we have a fractional exponent? For example, 9 to the 1/2. What does a fractional exponent mean? Well, what it really means is actually it's a root. So for example, 1/2, the 1/2 power is the square root. So for 9, it's just 3 times 3. Or since 9 is equal to 3 times 3, the square root of 9 is 3. But we can also take 8 to the 1/3, and since we have the 1/3 fraction instead of a square root, we have a cube root, the third root. And the cube root of 8 is of course 2. And this is because 2 times 2 times 2, 3 times, is 8. So now let's take a look at a few examples to understand better. So now our first example. We will take 27 to the 2/3 power. So earlier we looked at 1/3 or 1/4, but this is 2/3. So first, let's solve the easier question of 27 to the 1/3 power. That's the cube root of 27, and since 27 is 3 times 3 times 3, which is 3 cubed, 27 to the 1/3 equals to 3. But how does this help us? Well, it helps us the following way. Since we have 27 to the 2/3, 2/3 may be rewritten as 2 times 1/3, or 1/3 times 2. And then, by the law of exponents, taking an exponent to another exponent multiplies them. So we have 27 to the 1/3 times 2 is equal to 27 to the 1/3 all squared. But 27 to the 1/3 is just 3. And then when we square this, we get 3 times 3 is 9. So for example, 4 to the 5/2 equals, and we do the same thing. We have 4 to the 1/2 times 5, and this equals to 4 to the 1/2 all to the 5, and this of course simplifies. Since we have the square root of 4 is just 2, then we calculate this in the parentheses first, and then take it to the 5th power. And 2 times 2 times 2 times 2 times 2 is 32. You can just check that on a calculator very easily. So the final answer is 32. Let's do some more examples. We will take 48 to the 1/3. So in this case, 48's not a perfect cube. So when we take the cube root, which is the same as the 1/3 power, we have to do a little bit of work to simplify it, but it doesn't simplify all the way. So 48 is 3 times 16. We can further factor it as 4 2's multiplied and a 3 multiplied. So we have 2 times 2 times 2 times 2 times 3. Since it's a cube root, we can pull out 3 of the 2's outside of the cube root and get 2 times cube root of 2 times 3, which is just 2 cube root of 6. And this is as far as we can simplify. Alright, let's try another example. 2 to the 1/4 times 8 to the 4/3. So this time we have several fractional exponents multiplied together. First, let's simplify the 8 to the 4/3 because we have a base 2 and a base 8, but we want both of them to be the same base. And now we remember that 8, which is 2 times 2 times 2, is just 2 cubed. So 8 to the 4/3 can be rewritten as 2 to the 3rd. And then we take this to the 4/3 power. Since we have an exponent of a power, then we multiply those two powers. So we have 2 to the 1/4 in the very front times 2 to the 3 times 4/3. And that, of course, simplifies to just 2 to the 1/4 2 to the 1/4 times 2 to the 4th. Now we remember the rules of exponents. When we multiply them together and there's the same base, we add. So it's 2 to the 1/4 plus 4. And this simplifies as 2 to the 17/4. This is one form of a good answer, but some people are unsatisfied with 2 to the 17/4. So another good way of writing the answer would be to keep the 1/4 power separate and just calculate 2 to the 4th. And 2 to the 4th is 16, so I get 16 times 2 to the 1/4, which can be rewritten as 16 times the 4th root, since it's a 1/4 power, the 4th root of 2. This is also a valid answer. Thank you for watching this video lesson. I hope it helped.